Hi again and welcome to the second episode of the 2020 JEE Advanced series, and the second chapter which we are dealing with is matrices and determinants. Here we are dealing with two questions. The first question is present on your screen, and this second episode I have brought on matrices and determinants for a reason, because it's one of those handful of chapters from which you can expect so many questions. They, like you can see in JEE mains, for example, if you can expect at least three, sometimes at least two questions for sure, and sometimes even three. Like one single most question will be from the system of linear equations, like that of consistency and inconsistency part, and others from matrix, adjoint and inverse, others from properties or determinants. If I say one will be from the system of linear equations, the other one is from adjoint and inverse, the other is from properties of determinants. And in JEE Advanced, you cannot fix the syllabus of matrices and determinants as such, but definitely at least two questions together in two papers can be expected from this chapter. So coming to solving part of this question, I hope you can see this question on my screen. So let's start solving. So what is given? The trace of a square matrix is defined to be the sum of its diagonal entries. So I think you know the definition of trace of a square matrix. Now A is given to be a 2 cross 2 matrix, a simpler matrix for now. And the trace of A is 3, very good. And trace of A cube is minus 18. So you just find the determinant of it. Looks like a simple one. Now I'm assuming a default matrix, 2 cross 2 matrix, that is sum A, B, C and D. For convenience, I have to assume some variables for sure. Notice the trace of this matrix in terms of variables. I think you know what's that. By seeing this matrix itself, we can say that the trace of the matrix is A plus D. Now, since the question is given that the trace of A is 3, so I'm thinking this is true. So I'm labeling this as equation 1. Now what will be A cube? I don't want to waste much time on calculation of A cube. I know sure you have to do the calculations in JEE Advanced, but this is a solution giving session, so I don't want to waste much time on calculation of this. I'll just give the inputs of the elements, only the diagonal elements. The other elements are not of my interest, because I just have to find the trace of A cube, nothing else. So the elements here I got are A cube plus 2abc plus bcd, and the other element was D cube plus 2bcd plus abc. This is the matrix that I got, and the other two elements I don't want to focus on, those are out of my interest. So what's the trace of A cube from here? So from seeing the matrix itself, you can say that it is A cube plus D cube plus 3abc plus 3bcd. I'm taking common 3bc from, so I'll get A cube plus D cube plus 3bc into, I'll get A plus D is common, so I'll just replace A plus D from this equation as 3. Okay, moving down, what I get? Trace of A is given to be minus 18 from the question. So I will replace trace of A cube with minus 18. What I will be getting? Minus 18 equals to A cube plus D cube plus 9bc. Okay, I'm labeling this as some equation 2. Okay. Moving down further, now I want you to recap one identity that you learned in class 9th or 8th as such. That identity is of A plus D whole cube. Either you can recap that identity or just use simply binomial theorem for computing this. What is a plus t whole cube? Well, I think you remember that it is a cube plus t cube plus 3ad times a plus t. I think you remember this. I hope you remember. Now I want to replace a plus d with 3 again. So what will that be? A cube plus d cube plus 9ad, right? So this is one such equation. What is a plus d whole cube now? Now a plus d is 3, so what I'm getting, it's just 27. Okay, now from here I want to get what's the value of a cube plus d cube. From here I get a cube plus d cube is equals to minus 18 minus 9bc, right? Now I want to substitute the value of a cube plus d cube in here. So what I'll get? So it is 27 is equals to minus 18 plus 9 times AD minus BC. So yeah, BC. So what I'll be getting further, moving down further, I'll get 9 times AD minus BC is equals to 45. Getting AD minus BC is equals to 5. Now why I want to find this AD minus BC? It's so arbitrary. Now if you see the first matrix moving up, what's the determinant of this matrix in terms of the variables? I'll say the determinant of the matrix is also AD minus BC, right? So what are they asking this? They are asking the determinant of this. We have got the value of this to be 5, so determinant of A is 5. So simple, right? It's very simple that you have to find determinant of A. So what I'm getting, determinant of A is 5. There are no options for this question as this is a numerical type question and you're getting a very good integer answer, so that's a good signal that your answer is correct. So I think you got to know how to solve this question. There's another method using the Cayley-Hamilton approach. It might be possible that some of you might not know this approach, the Cayley-Hamilton theorem approach. Cayley-Hamilton theorem approach is also very good approach in this, but since many of you might not know this approach, so I didn't use this as such. This is the most basic approach by just using the definition of trace and determinant and assuming a very arbitrary matrix A using 4 variables. So coming to the third question, contemporary third question for the series, which is, this is a simpler question compared to the previous question because it takes less time to solve. Now this is a 3x3 invertible matrix, real entries, I is 3x3 identity matrix, and this sole important condition is given. Then which of the following statements are always true? Now they are highlighting this using capital letters, so there must be a reason for that. We'll get to know why. So just ask me which of the following statements is true. So I have been given only these conditions, I have to manipulate these conditions to get my options. So what is this? M inverse is equals to adjoint of M. Now this is just one matrix, this is another matrix, both matrices are equal. So if I say a matrix A is equals to a matrix B, I can definitely say that their determinants are also equal. Yes. So if the determinants are equal, what is the determinant of this? Determinant of this is 1 by determinant of M. I think you know how by. What is the determinant of this? Now again I am using another property of adjoint of the matrix. Yeah. What is the determinant of this? Now if you remember, this is the determinant of A times n minus 1 whole square. Now n is the order of the matrix. Order of the matrix is 3. It's 3. Okay, so I am substituting over here I'll get a to the power, sorry, I'll just write it directly over here. It's just determinant of m power 4. So determinant of m, I'm bringing this again here, power 5 is equals to 1. So what is given here? It's of real entries. So a matrix M having real entries will definitely have a determinant belonging to real numbers. So I'm ignoring the complex roots of this equation and just assuming that there is only one real root, that is determinant of M is 1. So from this you can get the second option correct. So one of the options I got. The other one we have to manipulate again. The other one, again I'm using this same condition. M inverse is equals to adjoint of M. Now I want to assume adjoint of M as some matrix B. Okay. Now what will be the B inverse? B inverse is 1 by determinant of B times adjoint of B. Right? Now determinant of B is determinant of adjoint of M, which is determinant of adjoint of M, which is determinant of M square. Right? Great. So determinant of M is 1, so this is also 1. Very simple. So I'm just ignoring this because it's just 1. So B inverse is adjoint of B. Adjoint of B, right? B inverse is adjoint of B. Adjoint of B, yeah, correct. So which is adjoint of M? Adjoint B. Now again resubstituting back, I'll get adjoint of M. Right? Now this is one matrix. This is the same matrix, so I can equate both. Right? So what I'm getting is M inverse is equals to B inverse. Now if two matrices are equal, their inverse also must be equal. So I'm applying inverse on both sides, so I'll get M is equals to B. Right? From this I can definitely imply this. Without any loss of generality, I'm assuming that both are invertible. If M is invertible, the adjoint of the matrix is also invertible. So the both matrices are equal, so M is equals to adjoint of M. What is M inverse? M inverse by definition is adjoint of M. By determinant of M is 1. So M times adjoint of M is I. Now I'm using this condition and this condition. What I'll get? I'll also get M square is equals to I, and adjoint of M whole square is also I. So what I'll be getting using these both conditions, let's see. So I'm getting option C and option D are also right. Now this is true doesn't necessarily imply this is true. So I cannot say this option is always true. So with this we are coming into our second episode of the series. Let's meet soon again with the third episode with a new chapter and having new questions. Thank you very much. And at last I only request you to please like and share and subscribe my channel. And for later updates, please also press the bell icon. Thank you very much.